Welcome. Please refer to the following exercise. We are still referring to the previous example with the original problem and this corresponding dual problem. Please make a pause and attempt this exercise by yourself, and we shall refer to the solutions afterwards. Now we would like to solve the dual problem by the simplex method. Recall that our dual problem is to minimize this objective function subject to this constraint inequality with greater than or equals to symbol, and both y1 and y2 are non-negative. First, we notice that all these right-hand side values are non-negative and the variables are non-negative, but this is a minimization problem. We multiply this objective function by -1, so we change this minimization problem into a maximization problem. Our target is to maximize z equals to -120y1 minus 130y2. Now, we would like to transform the constraints with greater than or equals to symbol into constraints with equation sign by subtracting surplus variables and adding artificial variables as follows. And please be reminded to subtract MA1 and subtract MA2 from the objective function. So this is the corresponding dual linear programming problem in standard form. Please refer to the following deduction by yourself. We finally reached the final tableau of this dual problem as follows, and there is no longer negative coefficients for those variables in the 0th row. Therefore, the solution is now optimal as long as we take y1 equals to 3/5, y2 equals to 8/5, e1, a1, e2, and a2 to be 0, and z equals to -280. And this -280 corresponds to the fact that the objective function z equals to -120y1 minus 130y2 minus m times a1 minus m times a2 has a maximum value of -280. And therefore, referring to our original minimization problem, the expression z equals to 120y1 plus 130y2 will have a minimum value of 280, and it is achieved by taking these values of y1 and y2. The results match what we expected. The optimum value of the objective function achieved by the dual problem is having a minimum value of 280, and this value is the same as the maximum value of 280 obtained from the original linear programming problem. Second, the value of y1 obtained in the dual problem when the solution is optimal is 3/5. And this value is the same as the coefficients of the first slack variables x1 in the 0th row of the final tableau of the original problem when the solution has reached the optimal. Whereas the value of y2, which is 8/5 for the dual problem when the solution is optimal, is the same as the coefficients of the second slack variable in the 0th row in the final tableau of the original problem when the solution is optimal.